Hello and welcome to the first day of Chapter 7. Chapter 7 is all about right triangles, and so you're going to see some things in here that you may have seen before. You're going to learn some new things such as trigonometry. The first section, though, is the Pythagorean theorem, which you guys probably have all seen by now. Simply put, it is leg squared plus leg squared equals hypotenuse squared. You guys might have heard a squared plus b squared equals c squared. The legs can be interchangeable, so a and b are interchangeable, but C has to be the longest side, has to be the hypotenuse. So identify the unknown side's leg of the hypotenuse, and then find the unknown side. Write your answer in simplest radical form. So I've taught you guys how to do that in the beginning of the year when we worked on those algebra skills. Here we're looking for the leg. So 3 squared plus x squared equals 5 squared. So 9 plus x squared equals 25. So if I subtract the 9 from both sides, I get 16. 16 is a perfect square, so we get x equals 4. And then here we have 4 squared is 16 plus x squared. We're looking for the hypotenuse, by the way. 4 squared is 16 plus x squared. Nope. Sorry, I need that to be 6 squared, which is 36. And then that's equal to x squared. So that would be 52 equals x squared. Now when I square root both sides here, I'm going to break up 52 into 4 and 13, and that's 2 root 13. And so that would be simplified radical form, or simplest radical form. When you're reducing radicals, look for a perfect square such as 4, 9, 16, 25, 36 that divides out of the number you're trying to simplify. Okay, this question here says a 16-foot ladder rests against the side of the house and the base of the ladder is 4 feet away. Approximately how high above the ground is the top of the ladder? Well, when I look at these answers here, A, B, C, and D, I already know that it's going to be D because C is the hypotenuse is 16. My answer, x, has to be smaller than 16 or it's not a right triangle, or it's not a triangle at all. So I know that's the answer. However, what you could do is x squared plus 4 squared equals 16 squared, and then you solve that. What I'm going to actually do is I'm going to put this in simplified radical form for you guys so you can see one more example of that. So I'm going to take 16 squared, and that's 256. And then subtract the 16, the 4 squared from both sides. So x squared equals 240. Square root both these sides. So I'm going to divide out some perfect squares. I think 16 divides out of there. I could be wrong. I'm using a calculator here. And it does. So it's root 16 times 15. If you multiply 15 and 16, you get 240. And that just takes a little trial and error. So using a calculator there is going to be your friend. So you have 4 root 15. That's the answer that I am going to accept. I'm not going to be doing this decimal rounding stuff because you guys will need to know how to use that simplifying radicals skill. All right. Proving the Pythagorean theorem. There's a lot of different ways of doing it. This one's kind of fun because it's very visual. So what we have here is we have a square. So this square, and its side length is a plus b. This side is a plus b because it's a square. And if I find the area of the square, just doing simple side length times side length, a plus b times a plus b. I'm going to use the box here because it's a binomial times a binomial. You get a squared, ab, and then b squared. So the area is equal to a squared plus 2ab plus b squared. Now if I find the area using the 5 pieces here, there's 1, 2, 3, 4 red triangles and then 1 blue square. Again, still gives me the same area as the entire square does, but this one's going to be c squared plus 1/2. Now base of these triangles is b, height is a, so 1/2 b times a, but there's 4 of them. So I'm going to take that and multiply it by 4. Now if I simplify that, 4 times 1/2 is really 2, and then a times b is ab. Oops, it's a plus. Now they're both equal to a. These two things are equal to a, so I'm going to set them equal to each other. A squared plus 2ab plus b squared is equal to c squared plus 2ab. And you're going to notice that the 2ab is on both sides. And you have a squared plus b squared equals c squared. So there you go. Find the area of this triangle. A lot of problems involve using the Pythagorean theorem without deliberately telling you to use the Pythagorean theorem. Like for this one here, what I'd actually do is I'd actually rotate this like that. It's a little bit easier that way. And that's 10. And I need the height of my triangle. So I'm going to call that h there. And I have 10 squared plus h squared equals 26 squared. Notice we're only working with this triangle right here to find h. So 26 squared minus 10 squared, use my calculator here for this, is 576. And that's a perfect square. 24. So height's 24. Now when I'm finding the area of the triangle, I'm going to do 1/2 base. The base is 20. And I just found the height. The height is 24. So half of 20 is 10. 10 times 24 is 240, and that would be the area. This page here is all about Pythagorean triples. You don't necessarily need to know this. You just need to know what a Pythagorean triple is. A Pythagorean triple is 3 integers, positive integers, that satisfy the Pythagorean theorem. So like 3 squared plus 4 squared equals 5 squared. Or 5 squared plus 12 squared equals 13 squared. It just can save you a lot of time, like 10, 24, this one would be 26. It's that Pythagorean triple right there. Or 9, 12, 15, I think it's, yeah, 9, 12, 15, it's that one right there. 14, 48, and then 50. So, like I said, you don't have to memorize all these, but these 3, 4, 5, any multiples of 3, 4, 5, any multipliers of 5, 12, 13, these aren't as common, like 7, 24, 25, 8, 15, 17 kind of are, but the more common ones are these guys here. So again, you don't need to memorize them. You could just apply the Pythagorean theorem and just do 9 squared plus 12 squared equals c squared, and you're going to get the same answer. So don't worry too much about this, just know what a Pythagorean triple is. And that's all I got for you guys. Thanks for tuning in to 7.1. Hope you enjoyed.